Hello students, welcome to my YouTube channel. In this video lecture, I am going to solve questions from basic ground radar services chapter from ground studies for pilots textbook. Okay, so this is a different resource, different from Oxford book and Keith Williams book. So there is a different textbook called Ground Studies for Pilot and there is a chapter called Ground Radar Services. There is a similar chapter in Oxford Radio Nav book as well, ground radar equipments or ground radar services. And also there is a corresponding chapter in Keith Williams as well, based on this concept. So first I am going to solve questions from this textbook. Then I will also be solving questions of this chapter or same similar concept from Oxford Radio Nav book and Keith Williams book. So let's start doing questions from this chapter, this textbook first. A very important question. Which of the following transmissions may a pilot expect to make during a precision approach radar final approach? Okay. So now precision approach radar final approach. This is a precision approach radar approach is a 3D approach, meaning the pilot will receive information, will receive commands with respect to his glide slope and localizer. Next very important point is that whenever the pilot gets precision approach radar services, he doesn't need to make any transmissions, he doesn't need to give any readback as well. Whatever ATC controller, okay, whatever ATC controller asks him to do, turn left heading so and so, turn right heading so and so, increase your rate of climb by so and so, increase your rate of descent by so and so. So whatever commands are given by ATC to him, he must execute those commands directly. There is no need for giving a readback. Okay, so no need for giving a readback. Very important. Except he may be asked by an ATC controller to confirm the position of his landing gear or undercarriage position. Okay, so he must, whenever ATC asks him to confirm his position of the landing gear, now whenever you're coming for landing, the position of your landing gear must be retracted. You must be able to see all three greens. Three greens means in your cockpit there is an indicator of your landing gear position. Okay, and whenever you retract your landing gear for your landing, you will be able to see three green lights in front of you. The two stands for main gear, left main gear, right main gear, and this one stands for the front nose gear. So whenever ATC asks you to confirm the position of your landing gear, you will reply to your ATC controller that your landing gear are down and locked, or you can just say three greens, meaning all the three landing gears, mainly the nose gear and two main gears are down and locked. So apart from this particular thing, you won't be required to you won't be required to give any readback to any ATC transmission. All you have to do is execute those transmissions as soon as possible. So the correct answer here is, which of the following transmissions may a pilot expect to make glide path descending? So you need not make any readback or transmission related to your vertical profile. If you are correctly established on glide path and you are following that glide path correctly, ATC will inform you about that. Let's say you are above the glide path. So ATC will tell you to descend little bit or increase your rate of descent. Okay, so whatever information ATC you have to follow that. So you need not tell ATC that glide path descending. Next, approaching decision height. So this is also not needed. Okay, to tell this is not required to tell ATC. Three greens, yes, three greens stands for your landing gear position indicator. Landing gear position indicator. So three green is landing gear position, not PAPI lights or any other VASI, PAPI or any other kind of light, any other kind of approach light. So don't get confused between your approach lights and landing gear lights. Here three greens refers to your landing gear position. So option B is the correct option. Next. Question 2. Which of the following isn't an advantage, which is a disadvantage of precision approach radar? It requires no special aircraft equipment. It is a runway approach aid. It allows a lower decision height than a surveillance radar approach. When the runway is changed, the precision approach radar can be used on the new runway instantly. So the for option number A, precision approach radar. To conduct a precision approach radar approach, you do not require any special equipment on board. That is true. So this is an advantage. Okay. It is a runway approach aid. Yes, precision approach radar will be used to perform a runway approach. So option Bravo is an advantage. Option Charlie, it allows a lower decision height than a surveillance radar approach. So this is also an advantage. A surveillance radar approach, in case of a surveillance radar approach, you will be only getting a horizontal horizontal guidance, and you will receive advisory information. Okay, advisory information about your position with respect to glide slope. With respect to glide slope. In case of precision approach radar, you will be getting both horizontal guidance and vertical guidance. Okay, so precision approach radar is more precise than a surveillance radar approach, and therefore the decision height in case of precision approach radar will be more than the decision height for a surveillance radar approach. For a surveillance radar approach. Okay, next. So option delta is the correct option, meaning option delta. When the runway is changed, the precision approach radar can be used on the new runway instantly. So that is wrong. This is a disadvantage. That, let's say the runway in use is, currently the runway in use is 09. Okay, runway in use is 09. Winds change after, let's say after half an hour, 1 hour, the winds change, and now the runway in use is runway 27. Runway 27. So the precision approach radar can be used to execute or can be used to conduct precision approaches for runway 09 as well as runway 27. But the thing is, if the runway changes, whenever runway changes from 09 to 27, the precision approach radar can be used for this reciprocal runway, the new runway in use now, after half an hour. Okay, so there will be a time gap of half an hour time before the precision approach radar equipment is available for conducting approaches on the reciprocal runway. So option delta is a wrong option. It's a disadvantage that precision approach radar cannot be used instantly. You have to wait for half an hour before that approach radar can be used on a reciprocal runway. Next, question number 3. A controller may ask a pilot to carry out one or more actions when the pilot requests a radar service. Which of the following would not be requested? Now, whenever a pilot requests for a radar service, the controller, it's the prime job of the controller to identify the pilot, the pilot of that aircraft or the aircraft on his radar screen. Okay, now on the ATC's radar screen, there will be many radar blips representing aircraft, representing various aircraft under supervision of that air traffic controller. Now, out of this all aircraft, there is a responsibility of the ATC person to identify, okay, or to relate a particular radar blip, okay, any radar blip or a particular radar blip out of all this with the aircraft transmitting, okay, and how will the ATC controller will be, how will he be able to identify or make that match? So the ATC controller will ask the pilot to make a specific turn. Let's say make a left turn, left 30-degree turn, make a right 30-degree turn. Okay. He will ask that to do. He will ask the pilot to do that. Second option is he will ask the pilot to squawk ident. Many aircraft have transponder in them. So whenever ATC controller asks the pilot to squawk ident, the pilot will press the squawk ident button, the ident button on his transponder. And when he presses that, the radar blip on the ATC radar screen will flash for 20 seconds. Okay, so that is the second way to which or by which the ATC controller will be able to identify the aircraft with a particular radar blip on the screen. So, which of the following would not be requested? A series of turns. Yes. ATC controller may ask the pilot to make a turn left hand 30-degree turn, right hand 30-degree turn. That is one way to guess to figure out the aircraft that is transmitting. Second is VOR DME position. Okay, that is also true. Okay, in order to identify the position of aircraft transmitting to ATC controller, uh, identify ATC controller, the ATC person may ask the pilot to transmit the radial he is situated and the distance from the VOR station. So, for example, let's say this is a VOR station. The pilot is situated on radial 090 from this VOR station. Now, when the pilot is situated on radial 090 from a particular VOR station, the position of that aircraft may be here, it can be here, it can be here, because radial 090 is this entire radial. So, anywhere on that radial 090 is the position of aircraft. Now, to get accurate, precise position, you will also need an additional information of DME distance, the distance from that VOR station. So distance and the radial information together will give you an accurate position. So let's say I am 10 nautical miles on radial 090. That means 10 nautical mile from VOR on radial 090 is my aircraft position. Is my aircraft position. So this way I will be able to successfully identify or pinpoint the position of aircraft. So that's why VOR DME position or VOR DME position or information is another way to get to find out the accurate position of aircraft. Third is squawk ident. So like I said, there is a identification button on the transponder. When you press that identification button, the radar blip on the ATC radar screen will flash for 20 seconds. So that is the third way to identify the position of aircraft. Okay. So all three options are actually correct. All three are different ways to relate a particular radar blip to a particular aircraft in the atmosphere. So correct option will be all of the above may be requested. Okay. Question number 4. What is a radar vector? Choose the most accurate answer. So there may be some answers which seem appropriate or proper, but out of that we have to select the most correct or most appropriate answer. The heading the controller wants the pilot to steer means to turn. The safe track down which aircraft should approach the runway. The line on display screen which represents the time based. The blip on the radar screen. So the correct option is the heading the controller wants the pilot to steer or to turn. That is radar vector. Next, what do we call the point at which the pilot must initiate a go around from a surveillance radar approach? Okay, surveillance radar approach. Decision height, reference point, minimum descent altitude, missed approach point. So correct option is missed approach point. Like I said, a surveillance radar approach, a surveillance radar approach is a 2D approach, meaning it's a non-precision approach, right? You will be only getting horizontal guidance in this kind of approach, and you will be getting second advisory advisory height information, advisory height information with respect to your glide slope. So in such kind of non-precision approach, Let's say this is your runway. Landing on runway 27. The approach course is runway 27. This is your glide slope. Here is your decision height or minimum descent altitude or minimum descent height. Now, when you are conducting a non-precision approach, when you come down this glide slope and you approach this minimum descent height, so at minimum descent height or minimum descent altitude, you must be able to find yourself visual with the runway. That means at minimum descent height, the runway environment, the runway, the threshold lights, the PAPI lights, the approach lights, the threshold markings, anything must be visible to you. And in that case, you will be visible with the runway. You will inform or you will make a decision to land on that runway. In case the runway is not visible to you or you are not visual with the runway, the visibility conditions or the ceiling conditions are very bad or unfavorable. In that case, you will decide to go around. Okay, when you go around, you may come back for another approach, or you may divert to an alternate aerodrome. Now, in case of non-precision approach, at minimum descent height, you will make that decision whether to continue landing or go around. If you choose to go around, you will fly level and you will go around at minimum or approach missed approach point missed approach point. So from here you fly level and somewhere very close to the runway threshold you will you will at once you reach missed approach point go around you will go around. Okay, so this is what happens. So for remember this, you must initiate a go around from a surveillance radar approach at missed approach point, which will be beyond minimum descent altitude or minimum descent height. Next, question number 6. ICAO states that a precision approach radar must be able to identify aircraft within a reflecting area of 15 meters square over certain sectors in azimuth and elevation. What are these sectors? So the correct option is 20° in azimuth, 7° in elevation, and 9 nautical miles from the runway. Okay, so remember this sector: 20° in azimuth, left and right, 7° elevation vertical, and 9 nautical miles away from the runway. So this is the ICAO specification. Next, which of the following would have the shortest required maximum range? So terminal radar, airport surface detection equipment, precision approach radar, and RSR. It can be route or area surveillance radar, airway surveillance radar. So which of the following would have the shortest range? So the correct option is airport surface detection equipment or airport surface movement radar. So these radars are only meant for identifying aircraft in the airport environment, specifically runways, taxiways, apron, maneuvering area. Okay, so they only need to have that much distance, as much distance as the airport is large. So meaning some very small distance within 5 nautical mile or so. Terminal aerodrome, terminal area radar again much longer than that. Route surveillance 200 to 300 nautical mile. Precision approach radar 9 nautical miles, 9 to 10 nautical miles. Terminal area will be again 25 nautical mile or so. Okay, so airport surface detection equipment or airport surface movement radar will have a maximum range of, let's say, 5 nautical miles. Okay, just limited to airport environment. So option Bravo is the right answer. This concludes our session or lecture for this particular chapter from Ground Studies for Pilots. I hope you have understood all the 7 questions. Do the theoretical chapter multiple times, revise, write the important points. I have marked all the important points from this chapter, Oxford Radio Navigation book, and uploaded it to my YouTube channel. Do watch that video lecture, and also watch the video lectures in which I have solved questions from Oxford book, Oxford back questions, Radio Nav, this particular ground radar services chapter, and Keith Williams Radio Nav ground radar services chapter. I wish you all the best, and I request you all to share this video with all your friends, all the other student pilots who are preparing for the exam, CPL, ATPL, airline, and please subscribe to this channel if you haven't yet. Thank you for your time.